Hello engineering and welcome to Math Skills for Civil Engineering. So what we're going to do is we are in this first lecture. What we're going to do is we're going to review some basic geometry and 8th grade conversion stuff that I think we should know, right? So let's get started. Geometry, right? It is expected that we can calculate the area of some standard shapes, right? So for example, the area of a triangle, right? We should be able to do that, right? Where it is 1/2, so area equals 1/2 base times height, right? Rectangles, what are those, right? Area equals length times width, right? Where this is a length and this is a width, right? And circles, anybody remember? Right, pi r squared is equal to the area, right? If we look at all of these, the thing to bear in mind, right, is that all of these are two-dimensional, right? In that we take a unit times a unit and we end up with a unit squared as our final unit, right? And you already know, whether you've thought about it or not, that areas are always squared values, right? So if I asked you, what are some units for area? You would say, oh, well, like inches squared or centimeters squared or feet squared, right? Because it's always something squared, right? Okay, and then if we move on to volumes, right? It's similar, right? If you think back to geometry, you probably learned that volumes, right, just means we add in a third dimension. Where really, we are still going to take the area of the first part, and then we're just going to turn it into 3 dimensions by including the height, right? So for a triangular prism, right, so that would be something that looks kind of like this and extends like that. I don't really know how to draw that. There we go. Something like that, right? What we're still going to do is we're still going to do 1/2 base times height, because that's going to do this part. And then we're going to take that and multiply it by the length, right? And that's going to give us the volume of a rectangular prism, right? A triangular prism, sorry. If we wanted to do a rectangular prism, we would have something like this, where same thing, right? The volume would be equal to, first we would start with our length times width, which would give us this part. And then we would multiply by the height, which would be that last dimension. For a cylinder, right, which is something that basically we have a round part and like that, right? Same thing, right? Volume is going to be pi r squared, because that's going to give us this, times height. Now, if you look here, volumes are always going to be 3-dimensional, right? Because we have 1, 2, 3. 1, 2, 3, and this counts as 1 and 2 and 3, right? So when we think about units for volumes, it's always going to be something cubed, right? Like we could talk about centimeters cubed or feet cubed or inches cubed, right? Because it's always going to be 3-dimensional. I can make that look better. Cubed. All right, so those are geometry formulas that you're expected to know. And one I forgot to put on here would be the volume of a sphere, where the volume of a sphere is 4/3 pi r cubed. I forgot to put one on there, but that's like a circle that is 3-dimensional. All right, next up, simple conversions. I believe you either learned these in middle school, I believe in 8th grade physical science, right? Or maybe even before that, right? What matters now, though, is that we're going to talk about this from a perspective of dimensional analysis, right? Meaning that there won't be any of this, let's move the decimal back and forth, or let's just, I'm just going to try to multiply or divide in my head. Nope. We're going to show on our papers, right, what the work should look like in a way where anybody can look at it and double check your work quickly, easily, and they can be sure you understand what you just did, right? So first, let's talk about all of these. All of these are conversion factors, okay? Where conversion factors, another name for them would be inequality, where one side equals the other side, and basically it's a fancy version of 1, right? Where 12 inches is the same as 1 foot, right? That's inequality. 3 feet is the same as 1 yard, equality, right? 1 inch is the same as 2.54 centimeters, etc. And there are whole bunches of them, and you actually, from the work that we're going to be doing over the next few weeks, you'll be able to like draw out your own conversion factors when you read a word problem. But we're going to start with ones that are familiar because that makes this transition a little bit easier, I think. So first, let's say that we wanted to convert 15 inches to feet. Well, I'm going to start with my given. This is my 15 inches. That's what I'm going to start from. I would like to get to feet. That's my question. So what I'm going to do is I'm going to put a multiplication sign and draw a line. And this space is where my conversion factor is going to go. Okay? That space is where my conversion factor is going to go. Now, it works just like fractions, right? Where if I have an inch unit here, and we can think of this as being 15 over 1, because it's a whole number. There's no denominator there. So what that means is I need inches down here, and I need feet up here. And as long as that's true, I'm going to cancel out my inches, and I will have converted to feet in a way that shows I understand my units or dimensions, right? So I'm going to go find a conversion that relates those things. 12 inches are equal to 1 foot. So note that all I did was fill in the relationship where they need to go based on what I'm trying to convert. 12 inches equals 1 foot, and I put that in, okay? We have often seen people write things like 12 inches per foot or something like that, right? And when we see per, that really means equals also, right? So now all we have to do is do the math. So that's 15 times 1 over 12 feet, right? And so then we would just type that into our calculators, 1.25 feet as our answer. Yes? All right. Next one. All right, and the next problem says we're going to convert 15 inches. So that's our given. And our question now is centimeters. So I'm going to start with 15 inches. And again, for organizational purposes, I can put that over 1 to help keep it more clear. And now I need to find something where inches versus centimeters, right? A relationship between inches and centimeters. So here, 1 inch, 2.54 centimeters. Inches cancel. And then I would just do my math, right? Which says 15 times 2.54 over 1. Oh, this is centimeters. And then so I would just do my math, which is 15 times 2.54. And I would get 38.1 centimeters as my final answer. Now, if we take a look at this, right, we should be able to see, well, does this make sense, right? So if I start with 15 inches and I convert to feet, we know that feet are a bigger unit of measure, right? Feet are a bigger unit of measure. So if I think about this as being a foot, if this is 1 foot, it's made up of a whole bunch of inches, yes? So it makes sense that if I go from inches to feet, I get a smaller value, right? Where if I think of inches versus centimeters, right? If this is 1 inch, 1 inch is made up of several centimeters, right? Which means that I should get a bigger number, right? In terms of being able to double check, does that value make sense? Okay, next up, we're going to convert 5 kilometers. This is our given to miles. So same thing. We're going to start with our 5 kilometers, put it over 1 to help keep organized. And now in terms of units, I know that a kilometer needs to go down here and a mile needs to go up here. So let's go find a relationship between kilometers and miles. Oh, we found one. 1 goes with my kilometers and 0.6214 goes with the miles. Kilometers cancel. My math says 5 times 0.06214 over 1. My unit is miles. So we'll take 5 times 0.06214 and we will get 3.107 miles, right? Which should make sense because most of you guys, if you're on cross country or you do track or just a lot of running for fun, right? You know that a 5K is approximately 3 miles, right? That makes sense. All right, next up, 6 feet to centimeters, right? Where 6 feet is our given, centimeters is our goal, right? So we'll start with our 6 feet over 1. And so then we would go look, well, do we have a conversion between feet and centimeters? So let's look. We have inches and feet and yards, inches and centimeters, kilometers. Oh no, there is not one between feet and centimeters. What might we do? Right, we just got to do this in more than one step. I do know how to convert from, say, feet to inches, for example, right? I know that 1 foot is equal to 12 inches. Those cancel, and that would give me the number of inches I have, right? And we could stop here, and I could take my 6 times my 12, right? Which would give me 72 inches. And then I could convert my 72 inches using inches versus centimeters, right? And that would cancel. And then I would take my 72 times 2.54 to get 182.88 centimeters, okay? Alternatively, right, depending on how well you understand what we're doing here, right, there is the option to just show it as one string of work, right, which will benefit you later down the line. But if you're just getting started here, that it doesn't matter, right? You can do it in multiple steps, and that's fine. We could also say 6 feet times 1 foot is equal to 12 inches. And then just tack that next one on there, right? 1 inch is 2.54 centimeters. When I do it like this, I see that my feet cancel, my inches cancel. The only unit left is centimeters. If I look at what math operations I'm going to do, I'm going to take 6 times 12 times 2.54, all divided by 1, which is the exact same set of math operations I did here, right? 6 times 12 times 2.54, right? So anyway, whichever of those works best for you in terms of what you understand. All right, thank you for listening. Be good. I will see you soon. In the next one, we'll talk some more about conversions using SI prefix table. All right, thank you for listening. Be good, and I'll see you soon. Bye.